17, we're given the function f of x is equal to 4x minus x squared, and they want us to evaluate it at x equals 0. Now it says find the numerical derivative of the given indicated point. Use h equals 0.001. Alright, so now, and they want us to find f prime is what they're saying. Right? So what we really want to do is we want to find f prime of 0. Well, we know that we can find that if we, and I got to remember the notation that they use, so let me just give me 2 seconds to double check it and look it in the book. So what we could do, we would say as h approaches 0 of f of a plus h minus f of a minus h all over 2h. Okay? Well, that's equal to us saying 4 times. Now, here's the thing. I'm going to add 0.001. So I'm going to say 0 plus 0.001 minus 0 plus 0.001 squared minus all this stuff, which will be, now we're going to take the negative of that. So it'd be 4 times negative 0.001, because it's still 0, but now we're subtracting it. And then minus 0.001 squared. Yeah. I ran out of paper. All over 2 times 0.001. Okay? Now if I clean that up a little bit and distribute it, what I actually end up with is 4 times 0.001 is 0.004 minus, what is 0.1 squared?
Wait, on the top, is that 4 parentheses negative 0.001 minus 0.001 again?
Yeah, so now this one will be minus minus, which actually becomes a plus. So this will be 0.004, but that becomes positive. And then we minus another minus, which becomes a plus, which will be 0.001 squared all over 0.002. Now, I'm going to do this on the calculator because sometimes I think when you guys rush.
Can you use Ender for this?
No. I mean, you can and you'll get the same answer, but Ender, well, let me finish my thought and then we'll talk about Ender, okay? So what I want to do is if I say 0.001 and then I square it, I get 6 zeros, right? Or 6 decimal places is what we should say, right? Yeah. Yeah, I think so. So if we, let's double check that. 1, 2, 3, 4, 5, 6. Oh wait. Yeah, well, I put the wrong number in. So yeah, so I've got 0.004, and that's minus 0.00
Forgot it's 0.
If you multiply 0.00 by 0.001,
TI 83
bigger?
plus.
Why would it
Well,
get smaller?
hold on, guys. They cancel anyways because I got a positive here and a negative here. So,
But why would it get smaller?
what do you mean?
Squared it. You squared a decimal.
Because it's the decimal. It's like it's 1/1000th times 1/1000. So it's like 1 over 1,000 times 1 over 1,000.
The calculator's obstructing my view.
Okay.
Sorry, I'm out of it today.
So I've got this.
Wait,
So now I've got 0.008 over 0.002, which guess what?
It's 2.
It's 4. I'm glad you find humor in that.
wait.
Spaghetti.
Okay.
But why didn't you do it without putting in the numbers?
Well, hold on just a second. Let's talk. This is what they wanted us to do. Okay. So we got to get used to doing the things the way the book wants us to. We can't always take the easy way out. But what they wanted us to do was find a numerical derivative using an approximation. And so our approximation yielded 4. All right. Now the approximation, remember, if I were to graph this, I'm going a little bit to the left and a little bit to the right. In other words, I'm doing 3.9. So let me show you what we're doing graphically, okay? Because this is important. This is where it all comes from. If I take 4x minus x squared, and I graph it, and what I'm really interested in is when x equals 0. And when x equals 0 and I add a little bit to it or I subtract a little bit from it, I'm going to get a certain value, right? So we know that the derivative of this at x equals 0 should be 4. And we could trace that. We could go second, trace, pulls up the calc menu, come down to dy dx, plug in 0, and we get 4. But where that really comes from, and let me zoom in real tight here so you can see it. Now let me zoom in one more time so you guys can see it really well. What we're really doing is we're taking the secant at negative, we're taking the secant of negative 0.001, which yields that 0.00401. So that is the 1 point here. And then if I do that again, I'm going to do it at the 0.001, which is the 0.39, which is the first point. So we're calculating the slope between those 2 points. And if you guys are like, what is he talking about? I don't understand what he's saying. What I'm saying is look at this. I am taking the 0.004 and subtracting it from this, and that's where I get that x and y value. But really what I'm doing, so this is going to be the point, see how the 1 is right here? I'm taking the 0.004 and I'm subtracting the 0.0001, and that's how I get this number. But what am I really doing? I'm simply adding 0.001 to x. So if you come way up here, I'm saying 0 plus 0.001 minus 0 plus 001. And then if I go to the negative side of that, in the x direction, that's all this stuff up here. 0 minus 0.001. Well, that x value is this. And that's where I get this from and this from. And then I evaluate it and I get the corresponding y values. Okay? Now if I take the secant line and calculate it, my change in y is 0.008 and my change in x is 0.002, and so my slope is 4. And that's all they wanted us to do. Now the question was asked, can I do that in nderive? Yeah, nderive will do the exact same thing except it goes through it you know, it's got a program that does that. So if I go onto the main screen and I wanted to double check my work, I just come in here and I go to second catalog, and then I think, is it this one that's the end? Yeah. If I come down here and I choose and derive, I first enter in the function, which is 4x minus x squared, right? Comma, tell them what to do. I got to use x, comma, then evaluate at 0, right? And it'll still spit out 4. Well, the problem is if you do your homework with your calculator like that, and on the AP exam it asks you to do it this way, well, good luck on that question. Right? You got to know how to do it this way. Okay, any questions on that?